Hi everyone, my name is Tom Doyle. I'm a fourth year chemical engineering student, and right now I'll be presenting my contribution to the iPro project here and some of um, the lessons I've learned and the challenges that I've overcome throughout this process. So what we're looking at here is a combined super scan of all of the sections together, and this is about a total of 200 scans. Um, and this is well over before subsampling. This is well over about 1 billion points, and so a little bit later I'll talk about the challenges we've had with that and how we had to decide on a subsampling method and all of those things. But for now, this is just an overview of the combined building. You could see different angles of this, um, and so one of my jobs was actually taking all of the sections that other group members were working on and combining it all together. So that took quite a bit of time, but I think the overall result looks pretty good. So that is the overall super scan. So you can see some misalignment between the first and second floor here. If I kind of move it over a little bit, you should probably be able to visually see that. Yeah, this was probably the biggest challenge, was getting the second floor onto the first floor, just because um, they're two entirely different scans. But I think considering the amount of space that we had to scan on the second floor and the inaccuracies that we can expect with the iPad, it did turn out okay. Here's just a couple more angles, just to see that. So now what I'll do is I'll provide top view so you can see the first floor pretty clearly, and I'll take the second floor out of this view. So do that. This is now just looking at the top view of the first floor, and you can see there's a little bit of curvature in the hallways connecting the east and west side. I zoom out a little bit of curvature, but I think overall it actually turned out really well. A little bit in the pool you can see here, but yeah, overall it looks pretty solid. We didn't have many issues a bit with that, so yeah. So now I'll hide the sections that my other group mates worked on and focus specifically on the ones that that I worked on. And there it is. So if you look at the left side of the screen right now, this is the east side of heating, and then on the right side of the screen, this is the west side. So if I orient this would be about where you would enter heating, right here, and then if you take a right, you'll walk down this hallway, and there will be a set of stairs taking you to a lower level. This hallway is what connects the east entrance from the auxiliary gyms and the dance room on the lower level. And this is a total of 8 scans merged together. And then the next one, this right here, this is the hallway connecting the east and west sides of Keating, and this is a total of 2 scans. Let's see inside there. And then a large part of the work was on the men's locker room here. This is actually a combination of 15 scans. So you can see that right there. This includes all of the lockers and the men's shower, the men's bathroom, and other parts of the locker room. And then this part is where it would connect to the pool area. And then finally, here's the west area of the building. These scans were taken during the second assignment, so they came out pretty well, so we just left them in the final result. This is a total of 5 scans here on the west side, and I'm not sure if I mentioned this, but 15 scans total for the men's locker room. So now just to address some of the challenges that I came across, the first is determining an optimal subsampling method such that we can keep, all of these scans consistent. And I kind of played around with different subsampling methods, random subsampling, and then other types. And we decided to stick with random subsampling because it looked like it produced the best results. And what we did was we took 200 million points, which is the maximum number of recommended points to work with on Cloud Compare such that your system doesn't start to crash. And we divided that number by the number of scans that we had, which was roughly 200. And it came out to be about 1 million points per scan. And so given that each scan is roughly the same amount of points, it ended up working out okay to use this method. So each cloud is 1 million points after subsampling it down. So then the next challenge was that sometimes the scans wouldn't all open on the same plane. This was particularly an issue with the scans in the men's locker room. So like they were all on different locations on the X, Y, and Z axis. So it was kind of a big cluster. So what I did first was I put everything onto the same position on the Z axis so that it would be easier to work with. And to do that, all you have to do is use the translate rotation tool and just fix it such that you can only move it up and down on the Z axis. So I did that first with all of them. Then it made it a lot easier to merge all of the scans back together. And then the final issue is that you just have to look out for some situations where if you take a scan one day and then you pause it and then you take another scan another day, you might notice that some objects are shifted around. This is very common for doors, for example. When you take a scan, you might have a scan of a door being open, and the next day the door could be partially closed or even shut, and it would turn out different in your final result. So when this happens, this would be a good application to use the sectioning tool. So you can section out, for example, a partially open door and just leave either the closed or the open door as your final result. So these are just things that I've came across and had to actually do when I take scans separate days. So that's about everything from my end. This was a really awesome project, and I was fortunate to have a great team to work with. So thank you for listening in.